Hi everyone, it's Math with AUB, another frame based on second year past papers, courtesy Federal Board. Courtesy overall questions have been taken from Federal Board. Our question number 1 reads as what is the value of A, or what should be the condition or restriction on A to get this one maximum. It is a quadratic equation, everybody is familiar. Trajectory of projectile motion, equation of trajectory of projectile motion, we are familiar. We are interested in max. When double derivative is negative at some value of x, it's negative, then it is it has max at x is equal to it. Double derivative must be negative. For minimum, for max, for min, double derivative must be positive. Double derivative must be positive at x is equal to e. If double derivative is 0, then it is neither min nor max. It's known as point of inflection. It's known as point of inflection, or some right inflection. Okay, cool. Differentiate 2 times to get at the required condition for on A. Single derivative, sorry, dy over dx. A x square means 2x. Drag the drag the power down, subtract 1 from the power. Differentiation of x with respect to x1. Differentiation of x only x1. Differentiation of a constant is 0. Let me settle it down. dy over dx. It's 2 times ax plus b. Again differentiate. Dy dx square 2a. Differentiation of x is 0. Sorry, 1. And differentiation of constant is 0. Differentiation of x is 1. Now it's our double derivative. We have to find the condition when it is max. Max means double derivative must be less than 0. Less than 0 means negative. 2a must be less than 0, or a is less than 0 over 2 means a is less than 0. Whenever a is less than 0, it has max. When a is less than 0, it has max. If it is given, if we are asked to find its when it is min, for min, that's double derivative must be greater than 0. So 2a is greater than 0, a is greater than 0 over 2, a is greater than 0. Value of a must be positive for min. For max, a must be less than 0. To get inflection point, double derivative must be 0. Double derivative must be 0. So 2a is equal to 0. So value of a is 0 over 2. Value of a is 0. For maximum, a must be negative. For minimum, a must be positive. And for point of inflection, a is equal to 0. In that question, we have been asked to find max. Max means a must be less than 0. That's our required option in that case. Second question, based on selection from analytic geometry, straight line. Straight line. Find the coordinates. Find the coordinates means we are interested to find values of x and y of the foot of the perpendicular from a perpendicular line dropped from -2, 5 to the given line, that is 3x plus y plus 11 is equal to 0. Let me draw a rough sketch. Let me erase this first. Okay. It is a rough sketch. From -2 to 5, we have drawn a perpendicular foot of perpendicular or perpendicular line to this line. The given line is, suppose 3x plus y plus 11. A line has been dropped from -2, 5 to this line in perpendicular fashion. Perpendicular means making angle 90. Making angle 90. We are asked to find the value of this point. It's very easy to back solve, to utilize the options. If we put option here, minus 3 times -5, y is 4 plus 11, it's our -15. 4 and 11, 15. It is equal to 0. It is very easy to prove. How to arrive at the result? By orthodox fashion, by official definition, that is the line. Slope of this line can easily be managed. Let me convert this line into slope intercept form. It will become minus 3x minus 11. So slope of first line is minus 3. As they are perpendicular, slope of this line is minus 3. So the slope of this line is going to be, according to the definition of perpendicular, negative reciprocal of this slope. The slope of this line, suppose it is L1, it's L2. The slope of the first line is minus 3 and they are perpendicular to each other, So we can easily manage the slope of this line. We can easily manage the slope of this line. We can easily manage the slope of this line, that is negative reciprocal of minus 3, that is positive 1 over 3. Now, this is the point and the slope. Whenever we have given point and slope, we can easily manage the equation of a straight line. By utilizing point slope formula, y minus y1 is equal to m times x minus x1. That's our x1, y1 and it's our slope. Y minus 5 is equal to 1 over 3, x minus value of x1 is minus 2. Okay, shift 3 there, 3 times y minus 5 in bracket, x plus minus 2. 3y minus 15 is equal to x plus 2. Shifting on the right hand side or on the left, it's up to you. It will become x minus 3y plus 15 plus 2 is equal to 0. X minus 3y plus 17 is equal to 0. This is line. Now look at this. This line and this line. Equation of this line is given by x minus 3y plus 17 is equal to 0. Both lines are meeting at this point. Both lines are meeting at this point. Solve for x and y by taking both these equations. One equation is 3x plus y plus 11 is equal to 0. Another line we have managed, this one, that is x minus 3y plus 17 is equal to 0. So multiply this equation with 1, with 3. Multiplying with 1, no change, 3x plus y plus 11 is equal to 0. Multiply with 3, 3x minus 9y. 3 into 17, I think it's 51. Changing symbol, cancel out. Y plus 9y, 10y. Positive 11, negative 51, that's 40. So 10y is equal to 40. So y is 40 over 10. So value of y is 4. Value of y is 4. Put in any equation to get x. Let me put in that x minus 3y plus 17 is equal to 0. X 3, value of y is 4. 3 times 4. 3 times 4, 12 plus 17. Negative 12 plus 17. 5 is the result. Plus 5. Shift 5 on there. It is minus 5. So our required point is minus 5 comma 4. That is a method to be adopted for subjective. In case of MCQ attempting, just put the values to arrive at the result, because this point satisfies both this line as well as this line. Both this line as well as this line. What we have done, perpendicular drop from minus to 5. And suppose this is the line 3x plus y plus 11 is given to us. We have managed the slope of this line. It is given to us. These lines are perpendicular to each other, perpendicular to each other, perpendicular to each other. Then take the negative reciprocal of this one, the slope of this line. Take the negative reciprocal of the slope to get the slope of this perpendicular line. Point is given to us, minus 2, 5 and 1 over 3. I have managed the equation. Then solve the given equation that you have just found, this one, where it is, this one. Solve both of these lines to get the point, because point of concurrency or point of intersection is same in that case. Okay. Third question from vectors, direction cosines. There is a relation of direction cosine to be utilized in both next MCQ, third as well as fourth. Good questions. Good questions. Mostly present in our first year. At Sindh level, it is present in first year. At Federal or Punjab level, they are present in second year. But good question. Good question. Three-dimensional things. Okay. What is first one? Direction cosines are given by, these are the two famous identities, cos square alpha, cos square beta, cos square gamma is equal to 1. And second one is sin square alpha, sin square beta, plus sine square gamma is equal to 2. In that case, we are asked to find what is the relation of direction angles. That is the relation that I have just mentioned. Question number 2. If alpha beta are the direction, then what is the value of this one? Next MCQ is the fourth one, cos 2 alpha plus cos 2 beta plus cos 2 gamma. We are familiar from our first year. Cos 2 theta is equal to 3 good identities to be utilized for trigonometry. Sin 2 theta. It's equal to 2 times sin theta cos theta. Number 1. Number 2, cos 2 theta. It's equal to cos square theta minus sin square theta. We can easily manage from cos to sin, sin to cos. And the third one is tan 2 theta. It's equal to 2 tan theta over 1 minus tan square theta. Cos 2 theta utilize here. That is our cos square alpha minus sin square alpha. In case of beta, that's our cos square beta minus sin square beta. Cos square gamma minus sin square gamma. Write cos square first, sin square later. Like terms to be collected. Cos square alpha, cos square beta plus cos square gamma. Here minus sin square alpha minus sin square beta minus sin square gamma. Taking minus common from this, it's equal to 1. Minus, taking minus common from this, we have sin square alpha, sin square beta plus sin square gamma. It's equal to 2. 1 minus 2. The net result is minus 1. The net result is minus 1. So, minus 1 is the right option in that case. Within no time, we have attempted both MCQs, 4th and 5th. What about 6th? Good one. To me, it is not a case of integration. More than integration, it is a question of trigonometry to me. It is a question of trigonometry rather than integration to me. Why? Let's see and find out. We have integration or cot inverse of root 1 plus cos x over 1 minus cos x dx. While solving integration, when sine and cosine have even powers, we utilize these identities. Sin square is equal to 1 minus cos 2x upon 2. Similarly, cos square x is equal to 1 plus cos 2x over 2. 2x over 2. If I move 2 there, it will become 2 sin square x is equal to 1 minus cos 2x. Similarly, 2 cos square x is equal to 1 plus cos 2x. Utilize these two identities here. We have cot inverse root. Look at this. The angle is double, their angle is half. 2x. Angle is double, their angle is half. So we have 2 cos square x over 2. Half the angle. What about this? Negative for sine, 2 sin square x over 2. 2 to cancel out. Cos square is a perfect square quantity as well as sin square. Their root is possible. Cot inverse, it will become cos x over 2, sin x over 2. We are familiar. Cos over sin is the ratio of cot inverse. Cos over sin, that's cot x over 2 dx. Both cot and cot inverse neutralized, x over 2 dx. What is the integration of x? Write 1 over 2 outside. Integration of x is x square 2 plus c. So 1 over 4 x square plus c is our right option. 1 over 4 x square plus c. Where is the right option? Somebody has missed this one. Okay, I have managed. 1 upon 4 x square plus c. That is the right option. To me, it is question of trigonometry rather than integration. Look at this. First step, make or break. If you adopt this strategy, then it works wonder. Otherwise not. These are the famous formula 3 and the remaining 3 that I have just written prior to this. They are very workable in case of solving integration direct. Another question, actually seal of most of the students, what do you mean by domain and range? We are asked to find the range of this function. Range of this function, that is f of x is equal to 2 plus root x minus 1. 2 plus root x minus 1. We are asked to find range. Let me give you idea about domain of this function as well as range. Okay, cool. Question number, that's 6. F of x is equal to 2 plus root x minus 1. How to manage the domain of this one? There is a root but in numerator. There is a root but in numerator. So we need, it must be greater than or equal to 0. Greater than or equal to 0 works. Greater than or equal to 0. If this quantity is 0, 0 in the numerator works. 0 in the numerator works. 0 in the denominator doesn't work. That's undefined. That's undefined. If that is the case, 2 plus 1 over x minus 1. I would have written for domain x minus 1 greater than 0. X minus 1 greater than why? Because if it is equal to 1, division with 0 is not allowed. Look at the difference, simple difference. Root x minus 1 is present in the numerator. We are allowed, we are entitled to get x minus 1 greater than or equal to 0. Is equal to 0, we can afford. In that case, we cannot afford equal to 0. We cannot afford equal to 0. Okay. So, we are entitled to take this inequality greater than or equal to, greater than or equal to. So x is greater than or equal to 1. How to write, how to mention its domain? 0, 1, 1 inclusive, shade the 1, inclusive, 1 is included, 1 greater than 1 towards right, keep it up, keep it up. That's open instead, keep it up towards right. It's our domain. How to write this? 1 to positive infinity, 1 to positive infinity, 1 to positive infinity. Okay, we are asked to find its range. We are asked to find its range. F of x is equal to 2 plus root x minus 1. What is our starting point? Put 1. 2 plus 1 minus 1. So 2 plus root 0, that's the 2. The starting point is 2. Starting point is 2. Then keep on putting values, it increases, it increases, it increases, it increases. So our range is going to be 2 inclusive towards the right. 2 inclusive towards the right. You can put 2, 2 minus 1, 1, 2 plus 1, 3, keep on moving. From 2 to positive side. How to mention its range? 1, 2, that 2 is inclusive, 2 towards upper direction. Because that is value of y. I am mentioning on the y-axis. I am mentioning on the y-axis. So that is the range in that case. That is the range in that case. So option number C is the right option in that case. Next question, we have given, we have to hunt, it is parametric equation of what? Parabola, ellipse, circle, hyperbola, or whatever the case. Let's see and find out. Let's check their normal usual parametric equation. Parametric equation. Just keep on changing the value of theta. You are going to get the graph of these conics from their parametric equations. Let's see and find out how. There are equations. X is equal to a sec theta and y is equal to b tan theta. These are the parametric equations of hyperbola. These are the parametric equations of hyperbola having transverse axis along x-axis. Let's verify. X square over a square minus y square over b square is equal to. Manage, instead of x, a sec theta, a square sec square over a square cancelled out. What about b? B square tan square theta over b square is equal to 1. Cancelled out. We have sec square theta minus tan square theta is equal to 1. What utilize identity of either sec square or tan square. Sec square is equal to 1 plus tan square. 1 plus tan square minus tan square is equal to 1. Cancelled out. So 1 is equal to 1. These are the parametric equations of hyperbola. Normally, these are equations of parametric equations of hyperbola. If transverse axis changes, then this goes to x and x goes to y. What about next? What are the parametric equations of? Let me give you idea of parabola. Y square is equal to 4ax. These are the parametric equations of for parabola. 2at and x is equal to 80 square. These are the normal case of parametric equation of parabola. Let's prove. Put instead of 2a, y, instead of y put 280 square. 4a instead of x, at square. That is going to be 4a square t square. 4 times a into a, 4a square t square. That is a normal. Normal. Normally these are the parametric equations of parabola. Hyperbola, parabola. What about ellipse? It's really good one. X is equal to a sin theta, x is equal to a cos theta, and y is equal to b sin theta. When major axis along x-axis, when major axis along x-axis and minor axis along y-axis. Let's verify. X square over a square plus y square over b square is equal to 1. Instead of x, let me write a cos a square cos square theta over a square plus b square sin square theta over b square is equal to 1. Cancelled out. Cancelled out. We have cos square plus sin square is equal to 1. So 1 is equal to 1. There is a slight difference between the parametric equations of ellipse and circle. Look at this. X is equal to r cos theta, y is equal to r sin theta. Sometimes these are known as polar coordinates as well. Polar coordinates as well. If the coefficient of cos and sine same, if the coefficient of cos and sine same, these are the parametric equations of circle. These are parametric equations of circle. If they differ like this, if they are different like this, it is parametric equations of ellipse. Ellipse. Sec and tan stand for hyperbola, while 280 and 80 square are the normal parametric equations of parabola. Moving towards the 8th question. The length of major and minor axis of ellipse, and in the next question we are asked to find the length of lattice rectum. I can also give you the idea how to find a centricity as well. Let's see and find out. Second last question was same 8. Major and minor axis of the ellipse, that is x square plus 16y square is equal to 16. Okay, cool. Normally we need 1 here dividing by 16. X square was 16. 16y square was 16. 16 divided by 16. It is going to be x square was 16. Y square over 1 is equal to 1. Writing in the standard form, x square instead of 16, let me write 4 square. 1 is the perfect square quantity, 1 square is equal to 1. So my value of a is 4, value of b is 1. So length of major axis is going to be 2a, length of minor axis is going to be 2a, major and minor. Value of a is semi-major axis, semi-major axis. Then it's 4, a is equal to 4. If major axis, 2a, 2a means 8. Similarly, semi-minor axis, that is b only, 1, minor axis only, length of minor axis, that is 2b, 2 times 1, so that's 2. That's the way of finding major and minor axis, where a is always greater than 0 in case of ellipse. We are familiar. In the next question, we are asked to find the lattice reactive. Lattice reactive, and the equation is given in the standard form. X square over 36 plus y square over 25 is equal to 1. Instead of 36, let me write 6 square. Instead of 25, let me write 5 square. So value of a is 6, value of b is 5. Length of lattice reactive, length of lattice reactive, that is 2b square over a. 2, value of b is 5, value of a is 6. 2 times 25 over 6, table of 2, 2 times 1, 2, 2 times 3, 6, 25 over 3, 25 over 3, 25 over 3. So that's the answer in that case. And in the next case, 8 and 2 are answer. 8 and 2 are answer in that case. Length of major and minor. It's my tiny effort for you guys to give you idea that mathematics is not a line, it's a good, but work according to given definition, given parameters, rather than cramming or ratification. It's all by itself.